Hello everyone and welcome to the third tutorial of Basic Electronics module. In this particular tutorial we are going to see the introduction to the resistors. So in this session we are going to cover everything about the resistors from beginning to the end. For example, we are going to see the basic resistor, how does it work, its SI unit, its symbol, and in the advance we are going to see its application and how the color coding works. So this is the table of content. These are the four categories which we are going to cover in this session. The first one is resistor introduction. So what is a resistor, how it works, its assay unit and its symbol. In the second part, we are going to see the series and parallel connection. So what happens when resistors are connected in series and parallel. The third part is power dissipation and different types of resistor. The fourth part is color coding and application of resistors. So how the value of resistor is determined and the area where resistors are used. Let us first see the resistors introduction. This is the first part of our today's session. So, this is how your typical resistor looks like. So, as we already know that a resistor is a passive component which is a two terminal also. As you can see from its image, it has two terminals. The first one is over here, the second one is over here. And in between of these two terminals, it has color stripped element, and this particular color coding is there to represent the value of particular resistor. So as you can compare it with a daily life example is a speed breaker. So in a circuit you can compare your resistor with a speed breaker on your road. So typically a speed breaker does what? It minimizes or it slow down the motion of a particular vehicle moving onto the road. Similarly, this resistor connected in a circuit is providing slowing down process or is providing the minimum of current. So a resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuit, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate the transmission line. So these are the basic and the most effective uses of a resistor in a circuit. So in a circuit where you are using a resistor, so resistor generally performs a function which is to reduce the current flow, but the significant role of resistor is also to adjust the different signal levels or to divide the voltages in a circuit or bias an active element or to terminate a transmission line. So these are the useful areas where a resistor is significantly used. Now let us see the SI unit and symbol. The SI unit of a resistor is ohm, OHM, and it is represented by this symbol which is in this box. So this is how your representation of a symbol ohm is going to take place. This is the schematic way of a representation of a resistor. This A is a typical resistor which has a fixed value. So wherever you have a resistor of a fixed value, you will denote it as this type of symbol. Whereas sometimes a resistor of a fixed type is represented this way by a rectangle. But when your resistor is variable or rheostat, then it has a symbol of an arrow onto this particular part. So this is how you can see this is a rheostat or a variable resistor. Whereas there is a vertical arrow, then it will denote as potentiometer. So this is how a symbolic representation of resistor is takes place. Now below are two typical schematic representation we have just seen. For example, if its value is 1 R2, then it means 1.2 ohms. And if it is written as 18R, then it indicates 18 ohm. Means the value of a particular resistance is 18 ohms. This is how your representation of a resistor takes place. If you have in a circuit this kind of representation, then you will see that this R1 means its symbolic value. This is the schematic representation, and this is the magnitude or numeric value of this particular resistance. Similar for this is a symbolic value. This is the schematic representation, and this is the numeric value of this particular resistance. These are the commonly used symbols for a resistor, this and this. And this is how your real life resistor looks like. It has colored strips. Each color strip denotes a digit or a multiplier or tolerance. Means whenever you see a resistor, it has this strip for first digit, this strip is for a second digit, these are the two digit. For example, this is the 470 k ohm resistor, then this 4 and this is 7. Then it is multiplier. Multiplier means how much kilo ohm, mega ohm, milliohm. This is multiplier. And this is tolerance. So this is how a value of resistance you can predict. Now let us see working principle, or you can say Ohm's law. See, Ohm's law is very useful in terms of circuit calculation or resistance or voltage or resistance calculation. The behavior of an ideal resistor is described by Ohm's law. So Ohm's law is there for to create or to see the behavior of the ideal resistor. So formula for Ohm's law is V is equals to I into R. So voltage through any resistor is equals to I, means current flowing through that particular resistor into the resistance of that particular resistance. Now Ohm's law states that the voltage V across a resistor is proportional to the current, means voltage in and resistor is proportional, voltage is proportional to current, where the constant of proportionality is the resistance. Means the constant of a proportionality is resistance, then voltage is proportional to current for Ohm's law. An ohm is equivalent to a volt per ampere. Ohm means 1 ohm is proportional or equivalent to a volt per ampere. For example, if a 300 ohm resistor is attached, 300 ohms resistor is attached across the terminal of 12 volt battery, means voltage or volt is equals to 12 volt, and your value of a resistor is R is equals to 300 ohms, then a current, or you can say I. See, for this this we have R is equals to 300 ohms and voltage is equals to 12 volts. Then what is the value of I, or you can say current? What is the value of current? Then from this equation you can derive or you can determine the value of current, which is V divided by R. So 12 by 300, which will give you as 0.04 amperes, means this much amount of current will flow through that particular resistor. So this was a simple sum, or for a representation of V is equals to IR. Now let us see the series and parallel connection. What happens when you connect more than one resistor in series, and what happens you connect more than one resistor in a parallel connection. So parallel is this and series is this. So in series connection there is only one common node, whereas in parallel connection there are more than one common nodes. So this is how your series circuits completes, and this is how your parallel connection or parallel circuit gets done. So flow of this section would be what is series connection, its formula and connection, what is parallel connection, its formula goes and how one can connect in parallel connection, and then we will see the advantages and disadvantages. So first of all, let us see that how the resistors in series are gets connected. So for example, if you have R1, R2 up to Rn, means n number of resistors connected in series. So this is how a series connection gets done. Means the first resistor, then it's a second or the last terminal gets connected to the first terminal of the second resistor, then your second resistor, then its ending terminal gets connected to the next one's first terminal, up to the last second last, means n minus one's second terminal or last terminal gets connected to this first terminal of Rn. So this is how your series connection gets done. So this is the schematic representation of a series connection. Hence, now whenever the resistors are connected in series, the total resistance, means these R1 to Rn, the total resistance R total, or the formula for the total resistance connected in series, is equals to simple algebraic sum R1 plus R2 plus R3 plus up to Rn. So R total will be equal to R1 plus R2 plus R3 plus up to Rn. So this is the simple formula of algebraic sum of the resistors, n number of resistors connected into a series connection. So in a series connection, the resistors share a common node and current through all the resistors is same. As you can see over here, in a series connection, there is no other path for current to flow through. Hence, in series connection, the current through all the resistors from R1 to Rn. So the current flowing through R1, R2 up to Rn is same. So in series connection, there is no other path for current to flow through. Hence, the R1, R2 and Rn has similar current. The total resistance of resistors connected in series is the sum of their individual resistance value. From the above equation, it is clear that the effective or total resistance of circuit is increased when the resistors or n number of resistors are connected in series. So whenever there are series connection or there are n number of resistors connected in series, then effective or total resistance will be increased. Hence, in order to increase the circuit resistance, resistors should be connected in series. So whenever there is an application of increased resistance, then you have to create a circuit of series connection, or you have to collect or connect the different n number of resistors into a series connection. Let us see the advantages and disadvantages of this type of connection. Same current flows through every device, means from R1 to Rn there is the same current flow, only one pathway. If breakdown or fault, see, this is the main disadvantage of the series connection, which is if breakdown or fault occurs in one device, it would affect the entire device in the circuit as they are connected in the same branch. For example, if any fault occurs in this part or in this load or in this resistor, then the entire circuit will be disruptive or will be interrupted, because there is only one path for current to flow through. Hence, because of damage in this area, the current will not flow through this, and hence the entire circuit will be switched off. Hence, this is the main disadvantage of series circuit. These are used where the same current and different voltages are required. So here current has only one path to flow through, as in series connection there is same connection flowing through all the devices, but each device has different resistance. Hence the voltage across each device or each resistor is different, because R is different for each resistor. Hence in series connection the current is same whereas voltage varies, while resistors in parallel. So this is how your parallel connection gets done. Means it has more than one common node. See, for this R1, R2 and Rn, they share more than one common node. One is over here and the another one is over here. This is how your connection is gets done, and hence it is a schematic representation. And the formula for this parallel connection is 1 divided by R total is equals to 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. The resistors in parallel shares two or more common nodes, and voltage across each resistor is same while the current is different. Now let us see that if current is coming from this particular node, then it has two different paths to go through, right? Hence the each and every part or each and every resistor has different value of current. Hence in parallel connection, each each of these devices has different value of current, but they have same voltage drop across them. Okay, so in R1, R2 and R3 current will be different, but voltage drop across them will be same. The total resistance of resistor connected in parallel is the reciprocal of the sum of the reciprocals of the individual resistors. From the equation, it is clear that when the resistors are connected in parallel, the effective or total resistance of the circuit decreases. From this formula, you can see that when you connect number of resistors or n number of resistors in parallel, the effective or total resistance will be decreased. Hence, in order to decrease the resistance of the circuits or the resistors should be connected in the parallel. Advantages and disadvantages. Now, in this parallel connection, there are same voltage drop. Two or more pathways are available for current to flow through. And this is the advantage that if breakdown or fault occurs in one branch or a device, it would not affect the device in other branch, as other devices are on the different branch. Hence, these are used where the constant voltage and large current is required. So when there are constant voltage application, you should connect the resistance in the parallel form. Now let us see the third part of this particular session, which is power dissipation and different types of resistors. So the flow of this topic would be the power dissipation, different types of resistor, then we will see fixed type of resistor, then variable resistors and working of variable resistors. So first we will see the power dissipation. So basically power dissipation is nothing but wastage of some kind of power because of resistor in a circuit. So at any instant, the power P consumed by a resistor of a resistance R ohms is calculated as, see, we have the formula of power which is V into I. Power P is equals to V into I. And also we know that I is equals to V by R, right? From Ohm's law, V is equals to IR. Hence, we are putting the value of I as V by R. Hence, we will have power P is equals to V square divided by R, and also we have I square R if we put the value of V is equals to IR over here. So we will have two equations, P is equals to V square by R or P is equals to I square by R. So this power is converted into heat, which must be dissipated by the resistor's package before its temperature rises excessively. Resistors are rated according to their maximum power dissipation. So the ratings of particular resistors are, hence they does not excess or it they does not increase the temperature. So these are the different types of resistors. First one is fixed resistors, which are lead arrangement, carbon composition, carbon pile, carbon film, printed carbon resistors, thick and thin film, metal oxide film, wire wound, metal foil resistor, emitter shunt, and grid resistors. And also we have variable resistors. So in variable resistor, first we have adjustable resistor. So a resistor may have one or more fixed tapping points so that the resistance can be changed by moving the contacting wire to different terminals. Now, where continuous adjustment of the resistance value during operation of equipment is required, the sliding resistant tap can be connected to a knob accessible to an operator, and such a device is called a rheostat and has two terminals, and it has also emitter shunts and grid resistors. So that was adjustable resistor. Now let us see variable resistors. See, variable resistors are the type of resistors whose resistors you can vary as per your requirement. So these are the different types of variable resistors, which are rotary POT, dual gang POT, single turn POT, concentric POT, multi-turn POT, servo POT, trimmer POT, digital POT, preset POT, linear POT, and slide POT. And the second one is potentiometer. So second is potentiometer. So a potentiometer is a three terminal resistor with a continuously adjustable tapping point controlled by rotation of a shaft or knob or by a linear slide. The name potentiometer comes from its function as an adjustable voltage divider to provide a variable potential at a terminal connected to the tapping point. So this is how your internal structure of any potentiometer looks like. They have three terminals, A, C and B, and it is a rotary gear. The first point, the second terminal, the third terminal. Onto this point we connect VCC. From here we get output, and here the ground connection is done. So the working principle of any potentiometer is like, the basic principle of the potentiometer is that the potential drop, or you can say voltage drop, across any section of the wire will be directly proportional to the length of wire. So the potential drop would be equal or proportional to the length of wire, provided the wire is of the uniform cross sectional area and a uniform current flows through the wire. So the condition is only that the wire which is used in the potentiometer should be of uniform cross sectional area and a uniform current should be flow through the wire. The potentiometer is an instrument used for measuring the unknown voltage by comparing it with the known voltage. So potentiometer are also used for measuring the unknown voltage. It can be used to determine the EMF and internal resistance of the given cell, and also used to compare the EMF of different cells. The comparative method is used by potentiometer. The reading is more accurate in a potentiometer. So the potentiometer's readings are more accurate. Now let us see the color coding and application of resistors. So how color coding is used for the resistance value and the applications of this kind of resistors. So these are the general resistors which we see or we use. The first one is 4 band, the type of resistor which has four different types of bands, color bands onto it. The another one is 5 band color, means it has a different five types of color bands onto it. And the another one is 6, means it has six different color bands onto it. The first two, always see here, the first two always stands for digit. So the first one is for first digit and second stripe is for second digit. According to its color, you can place its value of first digit. If it is red, see, for example, for here it is red, hence red stripe is for 2, so its first digit would be 2. The second stripe is of green color, hence it would be the second digit and in green column, in green row, so its second digit would be 5. Now its third band is of orange color. Now third band is generally for the multiplier. So which kind of multiplier we would use for that? So here we have the orange color band. Hence we will use 1k. Means after 2 and 5 we will use 1k. Okay, so it will get multiplied 2 5 into 1k. Okay, 2 5 into 1k means 25k in general. So it would be 2 and 5, 25, And the last one is for tolerance, means how much tolerance it has, and it is almost of brown color. So it would be of this is, sorry, this is golden, and hence it is plus or minus 5, means that this much of tolerance it can tolerate, means plus or minus 5%. So its value would be 25 kilo ohm. Now let us see this 5 color band. So first two are for digits. So this is yellow stripe. Then what would be the digit? It would be 4. Then after it is blue. Blue will stand for the second digit, which is 6. Then it is 4 and 6. Then after it is third digit. If you have more than 4, then the third one would be for third digit. Hence here it is 5 color band, then first, second and third. This three all will stand for the digits. This is first digit, this is second digit, and this is third digit. Now you have black. So if it is color black, then it will signify the value of 0. Then you will have 4, 6 and 0. So its digits are like 460, 460. Then this would be a multiplier. Orange would be multiplier, which is 1k. So 460 into 1k, which is 460k. Okay, 460 kilo ohms. And the last one is tolerance. And this is of brown. So brown would be plus or minus 1. So this would be plus or minus 1. So this is how color coding or the color, different types of color stripes are used to know the value or to determine the value of that particular resistor. Or else you can use digital multimeter. Using this both terminals, you can also know the value of a particular resistor. Now let us see applications of resistors. So resistors are used in circuit functions, also in LEDs and transistors, for dividing different voltage and heating purposes. So let us deeply see the different kind of applications. So there are different types of resistors that work according to the usage range. In this, we can set the resistance value by using a kind of feature called knob. Any changes in resistance value affect the flow of current in inside circuit. The use of resistor in circuit functions are in controlling speed of motor, pitch of musical tone, or loudness of an amplifier. An overflow of current through LEDs and transistor can be very dangerous. So an electric component called resistor is employed to overcome this danger. Means to protect LED or transistor or any circuit element from overcurrent, you can use the circuit element called resistance to protect the circuit. Also, because of collision of ions inside the material, some obstruction generates is the resistance, and this in turn products a lot of it when conducting current. We find it we find it useful as a heater. So in heater or toaster or microwave, this kind of application of heating is used. Fourth, dividing the voltage works when some components are required to operate in a much lesser voltage than supplied voltage. So whenever you require to less the voltage or lessen the voltage area, then you can use resistor to divide the voltage also. So these were the applications of resistors, and this was about the resistors, its assay unit, how its series and parallel connection works, how the color coding works, and where are the resistors used. So thank you so much. We will see you in the next video.